and he said that he may not be able to join. So I have this pleasure to introduce Dr. Susko. Dr. Susko is a teaching professor at University of California, Santa Barbara, and the Chief Technology Officer at Cadence Inc. He earned his PhD in mechanical engineering from MIT, where he developed the MIT Skywalker, a pioneering robotic system for gait therapy in individuals with neurological conditions. At University of California, Santa Barbara, he translated this research into a practical solution, inventing the variable friction shoe, now commercialized by Cadence. Today, he leads research and development efforts to advance this technology and its impact on mobility and rehabilitation. We're so grateful that, Tyler, you accepted our invitation and looking forward to your talk. Please share your screen and looking forward to learn from you. Oh gosh, I cannot hear you. I don't know, is it me?
No, Bijan, we cannot hear him.
How about now?
Great.
Is now? Yeah. Okay. Sorry about that. Yeah. Sorry, everybody. I was at my office and there's no internet. So I had to run home real quick to get on this call. So let me see if I can share here. I don't have both my screens set up, but we'll try our best. Let's see what happens if we go. Let's go here. And let's see if it shares the actual presentation. All right. Is everybody seeing the actual presentation, or is it still in the?
Yes, that's great.
Okay, great, awesome. So let me just change up the screen here so I can see. All right, so thanks everybody for joining me. I really appreciate the opportunity to speak to everyone today. And through Bijan's emails, I know that the group is quite diverse. So I tried to put it together a talk that's for researchers or investors or engineers or people that are starting businesses, entrepreneurs. And this is really the story of our business and the founding of it, which is called Cadence. So the title of the talk is From $1 Million Robot to 25,000 Pairs of $200 At-Home Shoes. And I know that this group is interested in streaming healthcare at home, and that's really what we've done with this project. So I'm going to take you through the talk here, and then we'll go through it. So we'll start here with my initial research. I know the group is a bunch of researchers. So my PhD was focused on rehabilitation robotics, specifically robots that interface with humans to deliver physical therapy for people with neurological injuries. That's a mouthful, but essentially a robot that's going to deliver physical therapy to people that had problems with their movement that derived from some sort of brain injury. And then after that, in 2019, we really translated this work to something that could be used in home. So the $1 million robot is great and it's a good learning vessel. But really, I think that the impact is to get into the home. So we translated what we were doing with the robot into something that was accessible and could exist outside of a laboratory setting or a hospital setting. And this talk also, I'm going to break it up into 3 real sections. There's research, which is really where the company stemmed from. But then there's also product design. At UCSB, this is really kind of what I am. I'm a machine and product designer. And so after we got through the initial research on the variable friction shoe, we just started to get into product design. And then once the product design was going, we formed a business. I hired a chairman, or he joined me, really. And we incorporated at that point. We paid for patents. We had originally filed provisional patents right before we published our first paper on variable friction shoes. But it was time that we had to pay for the real things, about $30,000 worth of patents all over the world. And so we formed a company. At the time, I didn't know what it was going to be called. And really, we hired a shoe designer that made the shoe very aesthetically nice. And he needed a logo the next day. And so I asked my 7-year-old, what do you think we should call these shoes? They're for people with brain injury. And my 7-year-old said, call it Brainy Shoes. So Brainy Labs was our first name, which we subsequently changed. But then after that point, after we got through the real world design, we started to do beta testing. And the reason why beta testing is under product design rather than research is the output of this testing was not to publish. The output of this testing was to validate a product. So we did that. And then at that point, the beta test looked good. We were giving shoes to people in the real world, having them walk, assessing safety and feasibility. At that point, we were able to hire a CEO. This was like a 2-year process where I was looking for a CEO and interviewing a whole bunch of people, just not formally, just informally having coffee with people. And it just so happened that we found the perfect person to lead our company at that point. In about 2023, he came on part-time as well, pretty much he was moonlighting. He was free for a year, just like all of us were, until we raised some money. So we raised some money. But at the same time, we were writing a grant that was funded by the NIH. It was an R01 grant to do a 4-year clinical trial. So that goes back in the research bucket. That's now underway and a couple of years in. And then at the same time, we were doing revisions on product design to make sure that the product was what it needed to be after our beta testing. And I'll be going through all of these in detail, at least a little bit more detail. And then finally, in March of 2024, we shipped our first shoes. So that was kind of like the launch of the business at that point. And so we continue to do research, trying to push our understanding of the technology. We're going to do a fall-related study soon. But in product design, we're doing new products that are similar to our old one, but have different uses. And then now we've sold more than 26,000 pairs of shoes. So that's pretty much a snapshot of this talk. And I'll kind of fill in some details now. So this was the $1 million robot. This was called the MIT Skywalker. So I'll show you 2 patients walking on this. This was the topic of my thesis in 2015. And this robot really was made for a few different purposes. To make it simple, what you're going to see is this robotic system that's watching a person walk. And the problem that most people have that we work with is the inability to clear the floor every time they step forward. It's called the swing phase of motion. So you're going to see this first person has left hemiparesis due to stroke. So that means her left side is affected. And she has trouble clearing that floor. So when people have this trouble, they usually have to invent solutions to get that foot forward. So that could be just throwing the hip out to the side or vaulting it up to get the foot forward. The robot works by watching the leg. And as soon as she initiates swing or moving the foot forward, the track will drop away. And it allows the foot then to just come forward like a pendulum, and the track comes back up to meet the foot, and then allows the person to do the steps, the stance phase, before dropping again over and over and over again. We called it the rhythmic motion of training, or mode of training rather. So here it's the same setup, but this person has bilateral foot drop. So we're dropping on both sides of the body. The cameras are doing everything, but we're also rotating in the frontal plane of motion. And when we do that, we're trying to disturb balance a little bit. So we're trying to make it a little bit harder to walk, but still allowing the ground clearance. So that's a little bit about where this began. And now I'll show you just how our variable friction technology works, and we'll back up after that. But I felt like this slide was useful. So this really follows just about everybody who said that everything should be about as simple as possible, but no simpler. This is like Occam's razor, back to William of Ockham. But Albert Einstein has said it. Tons of scientists say this, right? So we took that robot that, if it was installed in a hospital, would be about $1 million machine. And then we backed up and said, well, how can we do the thing that we were doing, but as simply as possible? So one of the people in our study at MIT just said, it's so easy to walk without having to worry about tripping every step. I wish I could bring it with me outside of the lab. So we said, okay, let's see how to do that. So we created this variable friction shoe. So the way that it works is there's this low friction material that's out on the side, and it kind of like is a catamaran design. So the low friction stays in contact with the ground during low ground reaction forces. As soon as you put your weight on the shoe, we have a soft foam here that's built underneath the pucks that can compress with weight. And the low friction puck then retracts up into the shoe, and you're now exposed to the high friction rubber tread, which grabs the ground. So I'll play you a little video and you can see how this works. So here it is in the low friction mode. We shape the shoes such it's like a ski tip, so it can get over these little imperfections in the ground and make its way for that next step. And you can see the mechanism of action right there. As people step on it, you can essentially retract those low friction pucks, and your friction comes back so quick that you can jump laterally and still grab the ground. So kind of to tell you the end of the story first, I showed you the mechanism of how the shoe works. This is a video of somebody that has multiple sclerosis on the top walking in their normal shoes. You can see it's really hard for them to get the foot forward. And then you can see what it looks like when they walk with the variable friction on the bottom, just how much faster they're able to move when they can get through that sticking underneath the foot. So we've been in market for 1.5 years. These are some of the comments that we've gotten in the middle. And I'll play you just a video of kind of the impact that we've been able to make here. And if the audio is not coming through, please let me know.
Yeah, unfortunately, we don't have audio.
No audio? Okay, let me see if I can change the share settings. Enhance content. I think let's see if I can. Share sound. Here we go. Let's try again. Okay, are we still seeing the same slide?
Yes.
Okay, cool. How about now?
These shoes have been a game changer for me. They've exceeded all my expectations.
Hello guys, how you doing? My name is Kwame and I had a stroke.
My name's Cindy. I have MS since 2016.
I'm Dennis Anderson. I've had MS for approximately 15 years.
It helped me to walk. That's the Cadence sneakers that I wear right now.
And in the last 3 months I've had these shoes, I haven't fallen at all.
The Cadence shoes, they allow me to be more mobile. These shoes are amazing. Look, they not only are great, but they look great too.
So I show this really just as kind of the end of the story first, and to show that, you know, the reason that we're doing all of this is the impact that we make on actual people.
There are true.
And by combining these 3 different areas, the research, the product design, and the business, we were able to make, I think, a greater impact than we would have been able to make in any one of these areas. So at this point in the talk, I'll kind of go over the variable friction. So when we were trying to translate the robot into a real product, the first obvious path forward was a robotic shoe. So this was our first attempt at it. In this shoe, in the Skywalker design, we were getting rid of the floor by dropping the track. We can't do that when we're out in the real world. But we thought maybe what we can do is we can have a platform shoe that retracts just like the robot did. And this was bad for a whole host of reasons. You know, software weight that we put at the foot that people are going to don now, that makes it challenging. The cost is going to go up, the complexity goes up. So we learned from there that's not the direction we want to go. So we kept going and iterating. There was about 40 iterations to get to where you saw the technology right now. And our first test that we ran at UCSB, we called it our beta test, was published at EMBC. And we were just putting variable friction shoes at that point onto people. No instructions. There were 2 different versions, the alpha, the beta. They did essentially the same working principle that I showed you a couple slides ago, where they have low friction until people put weight on it, then they get the high friction. And what we found, this was tested with multiple sclerosis, brain tumor, and cerebral palsy. And what we had found afterwards were people were walking at their maximum overground speed between 20 and 45% faster within 2 minutes and no instructions. So we thought, well, that's interesting. And 3 out of 5 people responded to it. 2 out of 5 did not. And then so we looked at the biomechanics of those people. We had a 6-camera setup, and we found that the people whose speed improved so drastically immediately was due to a change in their biomechanics. So one of the things I mentioned in the Skywalker video is for a lot of the people that we work with, what they're doing is they're circumducting, they're pulling their foot out to the side to get to the next step. When people donned the shoe, we didn't see that compensation happening anymore. So they didn't swing their foot out to the side as much. They started to involve their knee and started to go more straight in their gait. So if we look at that, this is a video from that study. This is somebody for just donning the shoe and getting on the treadmill. You can see her gait start to slide out to the side, that circumduction angle. This is the same video, but 1 minute later. You can see how her body has now changed her gait pattern such that she's coming with straight steps now. And her walking speed ended up improving by that 20 to 45% marker just in the 2 minutes. So once that was done, we tried to get into this real world design and we started forming this business. And in doing so, we started with this beta test. And the difference between the beta test and the pilot study that I was just talking about is that in the beta test, this was meant to test the product and safety and out in the real world. At the same time, I was just asking people to collect, hey, what's your speed look like? They were timing their gait, going about a 10-meter walk test, which is the clinical test that we use. And we tested with different conditions because I didn't know the limits of what this technology would be useful for. So we tested with all these different conditions that you see on the left. 13 people did our study for 1 to 6 months. And I would just get on the phone with them once a month and see how it was going, make sure that we weren't recording any falls or slip incidents or anything like that. And one of the participants that had a stroke walked in the shoes for 6 months and was really dedicated to the training paradigm that I gave him, which was walk at least 10 minutes a day in these shoes, at least 5 days a week for up to 6 months, however long you want to go. And we'll just track your gait speed as you go. And he improved drastically. He was 11 years post-stroke. There's no more natural recovery at that point. And we saw just a huge improvement for him, 3x the speed while using the device, 2x the speed when he removed the device. So we saw some evidence here that we were getting a rehabilitative benefit, which then we used as pilot data to submit to the 4-year clinical trial. And at the same time, we're making revisions and doing more research. So our clinical trial looks like this. So at UCSB, we have 2 different tasks that we're trying to do. One we just completed, which is a full characterization of the device, looking at how does the friction change with the application of force. And the graph that you're seeing on the top left here is coefficient of friction on the vertical axis versus the amount of force that you put on the shoe on the x-axis. And what we see with rubber shoes or leather shoes, they maintain that coefficient of friction or even decrease a little bit as you apply more weight, where our shoe does the opposite. So it's low coefficient of friction below what you see in other footwear, and then it starts to go up to approximate on different surfaces, it's at or above some of the other rubber footwear. And we built different rigs to do testing on the life of the shoes and how does this look after you wear it for a year. So we built this custom test rig that you're seeing in the bottom left. We're doing some AI gait modeling, which is really exciting and fun with a program called SCONE, where you can model the muscles of the body, the biomechanics of the body, and a neural controller. And you can use AI to iterate on a kinematic pattern that's going to optimize for some sort of walking goal, which a lot of times is not to fall. So we're just starting the AI gait modeling now. But our clinical trial is running at Shirley Ryan Ability Lab. We have, it's part of Northwestern University. So we're doing an ABBA crossover, which is a 4-year home-based study. We put people in our shoes for 12 weeks. There's a 2-week washout period, and then we put them in AFO, and half the population will start with the variable friction shoe. The other half will start with the AFO. And we're just looking at what are the outcomes when we do exactly what we did in the beta test, which was walk with the shoes. Well, in this test, we're asking them for 30 minutes a day, 5 days a week at home. And then the same thing with AFO. So we've seen some preliminary results. This was published at a conference earlier this year, where we're seeing some gains similar to what we saw in our beta test and pilot test for that. So this is ongoing. It'll go on for another 2 years before we publish the final results of the clinical trial. But on the product design side, we're switching over to the kind of that part of the system now. We had to really focus on aesthetics. It's something as a researcher, you're kind of like, aesthetics, because in my mind, and I'm sure the mind of many other researchers on the call, we're thinking about function and the efficacy of some device, but what we had found in our beta test, the number one thing people complained about was how ugly it was. So you see the shoe on the top left, it's pretty ugly. We had a zipper design too that turned out to not be too good. And so we worked with shoe designers that are really good at this stuff to make something that looks really good, especially for women. The constant comment I got is it needs to be cute. And sure enough, I think that's a huge driver of the business success at this point, is just how aesthetically appealing the products are now. So we've really focused in on that because we're something that goes onto the body. It's a wearable technology. It needs to look good. So we have to pair it with fashion, unfortunately. And then there was a lot of functional tuning to make sure that it was transitioning for low friction to high friction at the right weight. And then, of course, just a lot of robustness testing of the device to make sure that the shoe doesn't fall apart as people are walking on it over time. So that's really the product design piece of it. But then at the same time, you're running in parallel with the whole business stuff. And all of these things, what's been really a fun thing for me is it all just starts feeding on one another, feeds on itself. And I'll explain how in a second. But we started building the brand, came up with this Cadence brand. The logo and all that stuff was a competition we ran. It's called 99 Designs. You can submit what you're looking for and what your brand's about, and you get a whole bunch of artists that try to design your next logo for you. And really, we just selected what was the best, and we liked this one. So Cadence got started, the website started to get built and all that kind of stuff. And we hired a CEO who just was absolutely perfect for this. It was somebody, and this is advice that I always give to young entrepreneurs that are just starting out, is you want to find the person that's done the thing you want to do already and is really good at it, because I think that takes years off of your goal of building a business. For instance, our CEO had been a CEO of another company, and he was at the time that we were talking to a bunch of people in e-commerce. And we knew that we were going to take this product to e-commerce first. So he had everything set up already. All the systems were built. He had his advertising people. If we look at building the business, he knew how to get into 3PLs or warehouses. He knew how to run a Shopify site and build it. He knew what worked with advertising and social media strategy. He understood public relations. This is all stuff as a researcher that I had no idea how to do. So if I were to do it myself and become CEO, I would have just been years behind where we are right now. And at the same time, we're fundraising, we're pitching, we're doing all that stuff. So here's the full map. Again, we're now kind of coming towards the end of this map, and I'll tell you kind of where we are with all of these things now. So in research, we've started and initiated a fall-related study that's in IRB right now at Northwestern with our clinical team. It's a two-part study. We're doing a retrospective study. And when I talked earlier about all of these things kind of floating in and flowing with one another, it's kind of like a cycle. We got the idea to do a fall-related study because through the business, we had sold so many pairs of shoes and we were getting so much feedback. So we just get flooded daily with feedback from people. We have over 1,000 reviews on our website now. And that's in addition to all the social media comments and things. So we were just flooded with thousands of ideas. And one of the things that just kept coming up was, I don't fall anymore. I fell all the time. I would fall, many times per month. And since I having these shoes, I haven't fell. And that's what one of the gentlemen said in the video that you saw. And so we said, okay, well, maybe there's something to that. Like physically, that makes sense. If somebody's going to trip and fall, it's because their foot gets stuck on the ground and they're going to topple over. So we used all of the essentially data from the business and all these customer comments that were coming back and just listed them and applied for a grant to a foundation and won that grant to do a fall related study. So that's really a cool, just, I guess, nice relationship between the business and the research and then the product design. And then the product design, and this is kind of where my expertise is and what I teach. You take all of this, and if you have a really good understanding of your market and what they want, it's so easy to then go and design something. So we just listened to the market. The market has asked us for, hey, I'd love to have sandals. I want sandals. I want a summer option. So we just made sandals. It was that easy. I want slippers. Please give me slippers. And if there's 1,000 people telling you they want slippers, you just build some slippers. So, and then that becomes successful back in the business. So in terms of the business and where we are, 26,000 pairs now sold, more than that in the last year and a half. And it's kind of hockey sticking. It's going pretty well there. We're moving to a medical device. We've now registered with the FDA. That was something we avoided when we started because of the red tape. And we just sold this as, hey, it's a shoe to help people that have trouble moving their foot forward. That was it. But we kind of got over that gray line when the customer reviews started coming back and they were posted on our website. Things like, I don't fall anymore. Now that's a claim, a medical claim. And because it's on our website and we're publishing it on our website, that's something that kind of pushes you over the line. So we registered with the FDA, and we've hired essentially a chief medical officer now that is dealing with the medical side of things. So she's looking at reimbursement, how to get reimbursed through Medicare Advantage, Medicare, the VA, and all the channels for doing that, both, well, I guess in the United States, in Canada, and also in the UK. We started a professionals program where we got information out to physical therapists about this new tool and gave them a sample pair, that sort of thing. But right now we're really focusing on making that more of a certified program, where I'm building out a course right now that's going to teach professionals how to use the shoe in their therapy practice and who it's useful for. We also have this channel now of physical therapists that I can use to test products with. So for this prospective study, what I plan on doing is reaching out to our network. We have 450 physical therapists now enrolled in our program. And I'm going to say, do you have anybody that would like to join our prospective study, where we give them shoes and we assess their falls before and after wearing our shoes? So it's a really nice relationship there too, because our website directs people to physical therapists. Physical therapists get business from that. Patients get care from that. But we also have a network now that we can find people to test things. So that was something early on that's really hard. And if you don't work with a hospital, you have no access to patients. So this just gives us that broader access and more just feedback from the market. And then the last thing that we're doing, the business side, is we're expanding. So we started in the US, we got into Canada, say, the beginning of this year, maybe 9 months ago. We will be in the UK by the end of the year. We'll be in Korea by the end of the year. And then we have talks going in Japan, Thailand, and get into Australia as well. So it's kind of this growth now globally, which has been really cool. So in terms of C2SHiP's collaboration opportunities, Bijan had told me to conclude the talk with this. We have our fall-related study. We're going to be looking for frequent fallers for our fall-related study, the prospective version of that. So if anybody's on the call that works with people that have a high frequency of falling, we'd love to include your patients in that. They get paid and they get shoes. If anybody's interested in home-based studies, like OT-related type stuff, that's really interesting to us. For product design, I know that C2SHiP is really involved with remote sensing. We'd love to work together on the development of an in-home physical therapy system with AI and sensors. That's something on our mind. And then, of course, if there's any investors, we will be seeking investment within the next year or so. We just closed around about 3 months ago, which will keep us floating for a while. So that's it for today. I'd be happy to talk about or answer any questions or anything anyone's thinking.
Amazing, Tyler. Thank you so much for sharing your journey. Wow,
Sure.
that's impressive hearing that actually from where you started. I really like the concept of simplicity. This is the part that I'll also emphasize a lot to my mentees, that we as engineers, we tend to find the most complex solution for sometimes a trivial problem. Of course, it's not a trivial problem, but the fact to hearing also to patient what they want. And in particular, the design, the appearance of the shoes. I remember the very first study that we did about the benefit of the footwear for prevention of fall. It was when I was in Switzerland back to 1998, and there was a group in Germany that designed very elegant footwear for prevention of fall, and they designed them. They got a good results, but they didn't have any success because basically women said that it's not the shoes for me. Even not having a small heels, it was something that it was limited factor. And there was another study that we have done. I mentioned this study with you with OrthoFit that actually we pushed that, hey, we need to have variety of the shoe design, something that is also gender specific, and actually we got a great acceptance and acceptability, and adherence has been improved. And this is what I'm hearing from your talk. The idea of the sandal is great. One thing that I have a question for you. I mean, definitely the actually improving the friction and prevention of the slip is very important. and also giving a kind of a feedback on the type of the surface that they're walking, inclined surface, etc. Those are also very important for prevention of fall. But when we are coming with some of the conditions like peripheral neuropathy, that I saw that you consider that, I was wondering that whether this additional friction, it can also increase the shear when there is a contact between foot and sole. And we know that the shear, it could be very risky for those patient population. Actually, we would like to reduce the shear between the foot and insole to not causing the risk of diabetic foot ulcer. Have you thought about it and how you manage those kind of the balance between shear reduction and shear increasing?
Yeah, so when we think about shear, the shear is going to originate at the bottom of the sole, right? So with our friction value, and the graph that I showed there was only one surface, and it was actually the one that doesn't show as heavy of a difference. On carpet, the coefficient of friction between the bottom of the shoe and the carpet is 1.4 for a rubber bottom shoe. So that's the Hoka that we tested, which is huge. 1.4 means for every pound of force you put on it, you get held back in shear by 1.4 pounds. So 10 pound scuff, all of a sudden you have 14 pounds of shear on that shoe. And then to your point, the person that's inside of the shoe, they're now pushing their foot forward, and now maybe it's hitting the front of the shoe because of that shear. On that same surface, we were about 0.15 coefficient of friction. So 1/10 of the shear force that's coming into the shoe on that surface. And considering that a lot of home surfaces are carpet, if somebody's coming in contact with our shoe, they're just going to slide right forward. So that shear force that originated from the ground might be 1/10 of what it was in in that high friction shoe. So we haven't seen any problems with this, with shear or problems in it. But I see your point too. A lot of neuropathy, especially diabetic neuropathy, comes with the absence of sensation down there. So we don't know what's happening at the foot level, and that could be concerning, but we haven't seen that problem.
Great. I was wondering, there are some shear reduction in sole. I was wondering that whether a combination of that shear reduction in sole combined with your footwear, maybe this is something that can also reduce the heat generation, because again, if you have those slides inside the shoes, it can cause that heat that may not be necessarily comfortable.
That's a good point. So what happens with insoles with our shoes is a lot of people throw them out and put their own insoles in. So we just provide our standard insole, but they are removable, and then people just put in what they need.
That's great. Again, lastly, as you probably know, there are a smart insole that actually is coming to the market, generated by a different company. One of the companies that I know is Orpex. It came up with very elegant, very therapeutic insole that actually it can help to measure pressure and shear, and also now is reimbursable because you can having remote patient monitoring solution. It is something that you may want to consider.
You said it's Arpex?
Orpex. I can put it on the, actually it's a Canadian company that we did a study with them, and they show effectiveness of their insole to help to reduce actually risk of re-ulceration. And
Very cool.
it might be complementary, because I believe that if we can add a different component, and both of the solution is actually, it seems are reimbursable, yours and as well as them, and you can also maybe help to personalize the idea. The group in Netherlands, I remember that also they are thinking that adding those kind of components to decide that what is the wear of the shoes when there is a time to need to replace them. So those kind of the area that can help. I'm seeing that some great questions coming to the chat box. I would like to go to that discussion and also having brainstorming here. You bring in great case, in particular when you're adding the science with entrepreneurship and simplicity. It is becoming a very exciting area. So Rhonda, do you want to elaborate on your comment? I don't know whether he's on the call. He mentioned that I think this talk is very nice demonstration of the multiple hats the entrepreneur has to wear, including the range of innovative design, technology, clinical research, government regulation, product development, financing, fundraising, marketing, business development. Very nice comprehensive presentation. It's a great compliment, and that's true. By word, it looks simple, but it's very complex to take into account all those areas. Maybe Tyler, if you can share with this idea. I mean, for researchers, sometimes we don't think about those kind of regulation, and I really applaud you that you said that at the beginning we said that this is shoes, it should not be medical device, but then later on you decided to shift going toward the pathway of medical device. Can you elaborate that one? What is the pros and cons, and when you decided that now maybe it makes sense to go to the route of medical device?
That's a good question. So when we started, I met with a lot of FDA experts, 3 or 4 of them, and because I was really worried about this. I'm like, we're making something that's going to be beneficial specifically to a population that has a medical problem, right? So to me, I was like, I figured we should be right out of the gates going FDA. But the more I talked to these experts that were doing this, these were people that worked at companies that were medical device companies that had done this for 30 years. And they're just like, this is a gray area. If you stay on the one side of the line and watch what you say, you won't have to get into the regulation of this. And so if you sell it as a consumer product, it's a consumer product. You just can't say that this shoe is going to have some specific benefit that's a tangible benefit for a specific disease. And so we really tried to toe that line for a long time. And since registering, all it is, this is a class 1 device. So medical devices, when you register them, you've got class 1, 2, and 3. 3 is the most regulated, 2 is a little bit less than that, but still a lot of regulation. Class 1 is like a Band-Aid or a toothbrush. We're in that class. So with that, it's the lowest level of regulation. However, it's a lot. And it's made a lot of work for me, especially in a quality system. So the number one thing that you need when you're going the FDA route is you need to have a quality system in place. So the quality system is something where you're able to track product complaints, and those product complaints get tracked, and every month you need to look at them and decide whether or not you need to respond with a medical recall, or if you need to respond with a product change or something like that. This is all stuff we were doing anyway, but it wasn't a formalized system. And when you're a small, tiny startup, the more of these red tape type things you're doing take away from the main thing and don't allow you to propel, because you have to be held back by a lot of things. So I think that we did it the right way, because it allowed us to establish our company. And there's a timeline with all of this stuff you have to be worried about. So if you're not selling or generating revenue, you're going to burn through all your investment pretty quickly if you're hiring people. So getting out to market quickly is important. And when you get out to market quickly, you start to prove product market fit, which then investors like. When you need more money, you go back to them and you say, I need some more money. If you don't have that and you're just like, I'm sitting in the regulation loophole forever, trying to make sure that my product's quality standards are up to the par, and we're sitting here doing this for a year before we decide to actually go forward, they're just going to delay you. You're going to miss the boat. With our patents, I think I had mentioned at the beginning, we filed the variable friction patent right before we published the first paper on it, which is standard practice. You file a provisional. You get 12 months with that provisional. Then you have to file something or else you lose it. So you file what's called a PCT after that, a patent cooperation treaty, which holds your place. It's like a provisional that holds your place for 18 more months all over the world. That's part of the PCT in most countries. And so you get 18 more months after that. And then at that point, if you don't file the non-provisional applications, they're dead forever. So you need to have those patents filed before the end of that 18 months, or else it's dead. So Cadence was about 2 weeks away from being dead completely, which is when I met the chairman. He threw in some money, my family threw in some money, and we got the patents and we filed it we incorporated at that point. But it's all a timing thing. So if you're stuck in this wheel of regulation forever, you may miss the boat. And then at that point, you're out of money, you're out of steam.
That's amazing. Thank you for sharing that journey.
Yeah.
I would like to engage Shabnam. She's
Yeah.
consultant. This is what we are looking on panel. We have a great diverse team, and I remember Shabnam also is advising many startup on what direction they should go, which route of the medical devices they should go. Shabnam, do you want to chime in here? I mean, what do you think? Do you think that maybe Tyler is can consider the other avenue as well, and or this is the right business to go?
Good morning, Bijan. Thanks for calling on me. Good morning, Tyrus and everyone.
Hi.
Honestly, I'm sitting here at my parents' home, and I was, you know, being so close to aging parents, I was so much focused on personal needs and personal use of these shoes. I was just gonna about to send a message asking, do you have your clinical studies for fall prevention in Canada? So if you don't mind sharing that. Is this the right business? Yes. Is there the need? Again, just I have a hard time right now separating my personal interests and personal experiences of family members and so on. Definitely, there's a need. Every even little fall has such a huge burden on people and families. Being a class one, makes it, yes, it's been challenging, but a lot more easier for you to go to the different markets. And then the aesthetics part, I noticed you said, unfortunately, you had to consider fashion, but I'm a fashion designer, and I think that I was so pleased to see the progression. So let me stop here, Bijan, maybe repeat your question.
No, that's great. So this is what I would like to hear, because I know that that you have some dialogue with some companies that whether they should decide that this is simply a consumer product or is a medical device, and when we should decide to go to route of the medical device. I understand the value of reimbursement. I remember that I collaborated with OHI. Tyler, probably you know that, but they have very also elegant business. They find out that if they make it a custom-made foot plate, there is already reimbursement of $1,000. Originally was designed for a stroke patient. It's used for AFO, and then they extended this reimbursement for prevention of fall. And it's creating a great business. So that was one example that was very smart shift to shifting the device, but they needed to make it that move, because if they didn't make the custom-made foot plate, it wasn't reimbursable with that level, because you can go with prefabricated. So those are some of the fun line that actually need to be considered. And it seems that when they design, they didn't have necessarily a formal studies to make it actually FDA approved. As you said, there are some policy that need to address, but later on, since they have a lot of backlash from the society that whether this truly can prevent fall or not, they run then a randomized control trial to demonstrate the benefit. But it's very interesting aspect of reimbursement that sometimes maybe is wise to look at what is currently reimbursed and what kind of the initial modification need to be done to tap with already available reimbursement code. But thank you, Shabnam.
Can I add just a
Sure.
bit? I have a bias towards medical devices. I think the barrier to entry, I think it's great to start as a consumer, and a lot of companies have a path towards medical device. The barrier to entry is bigger. The adoption for a medical device, because you will generate some evidence and so on, is better. So yeah, I like everything Bijan said, and I agree.
Thank you. I'm seeing Mary, actually, you have also an interesting comment. Said that thank you for sharing your research. So Mary, do you want to elaborate on your comment? So she said that aside from the aspect of commercial success, user compliance is one of the biggest fails of wearables for assistance. And when aesthetic qualities, both formal and informal, are an integral part of product design, compliance is more likely. I fully agree with that. This is a part that I know that many designers, and Tyler, you mentioned that I really love, but you showing that you added zipper in a way that you think you can add some fashion, and it was not. So
Yeah.
for acceptability, I don't know. This is a part that I felt that there's a big gap in the footwear design. We are thinking from our mind, and we don't have any way to better interview participants about what they want. In the technology side, we have the technology acceptance model that they look at about perceived ease of use, even perceive it, not trying, just by look at how easy it is to use it, and perceived benefit. This is very important. And of course, if they are using a technology anxiety, and ultimately seeing that how those variables lead to intention of use and behavioral change. And our team came up to and adopt that technology acceptance model with the footwear. And this is what we did for evaluation of the footwear. Do you have those kind of the modeling to better evaluate what your patient wants and what can help them? Not saying that this is excellent, but willing to use it on daily basis.
Yeah. Yeah. So that's 100% agree. The number one thing you could do is make it look nice in our clinical trial. So also responding earlier to where our clinical trial is ongoing. It's at Shirley Ryan Ability Lab. Our fall studies are with those guys too. So we got a foundation grant. Our company is going to handle a lot of the. It's a fairly easy study to run because it's just, did you fall or not? It's a yes or no. It's binary. But we're working with Shirley Ryan Ability Lab on all of this. So regarding the aesthetics in those clinical trials, people have been asked like, no, I don't want to start the trial until I can get the pink color or something like that. Like, and then we have to delay their start because we have to wait for them to be able to have the pink instead of the black or something like that. So it's so important. Color is so important to people. So then in terms of how to assess, like, well, what's the right color? You work with people that know. So we work with shoe designers that are in the industry that are designing for Nike, Adidas, all the big brands, Under Armour, all that stuff. They know the colors. They know what's you can pay for software too, or I guess it's not software, but reports that tell you what the next color is going to be. So our designer doesn't do that. He just has a pulse on the world, and he's like, okay, I think this is the right color. And I'm like, oh, that's ugly. And then it does really well. So you know, it's kind of like I said before in my talk, it's finding the person who is an expert at every facet of what you're trying to do. So you find the expert. I'm terrible with aesthetics. So I made that comment as a joke. I think only function, like in all of my life. But that's not the most important thing. One of the tenets of design I teach all of my students in my design classes is things that look better work better. Simple as that. If it looks better, people just assume, and this goes back to what you were saying, Bijan, about the perceived effectiveness. If it looks better, the perception is that it's going to work great.
Oh, that's very interesting. I look at the website. I put it on the side. I saw that you have a pink color as well on your website. So that's
there was a pink one, which is like, okay, yep.
That's great. Actually, for the study that we have done, it was very funny. I mean, we have a Gait lab, but we are starting to bringing all the colors and design, and we creating like a window shop of the shoes. And when the subject came to our lab, we asked them to select what kind of, like what they are going to the shoe shop and saying that select what kind of the color do you like, what actually design do you like, and then when we select them, actually we custom made them for their foot, and we run the study like that. So we didn't show only one sample. There were, I'm guessing, 15 variety of the shoes, colors, and we said that select them. And that was very successful study, but it was a creative design that it was my first experience, but it's great. So Dr. Klonov, I know that you need to lead. He has always great ideas. I really enjoy that. Dr. Klonov, do you have any comments to add?
I would say the more digital you can make this, the better. with an app and keeping track of abnormal gait so people can learn from how they're walking. That's my suggestion.
Yeah, I love that.
Thank you, Dr. Kronov. And actually, Tyler, I mean, if you would like to publish in particular, if you have some application in diabetes and peripheral neuropathy, the Journal of Diabetes Science and Technology that Dr. Kronov is an editor-in-chief is a great actually journal. Actually, some of the earlier studies that he published in this area published in his journal. And I'm so grateful, Dr. Kronov, to be supportive for those footwear design, in particular for diabetes population. I know that we are on time, but we have Dr. Actually Zika Shinar that also he has a great comment. Go ahead, Dr. I hope that I pronounced correctly. I'm not very good in pronunciation.
Yeah, it's okay. Shinar is okay. So great presentation. Thank you. And I just wanted to mention and maybe follow on the comment of Dr. Klonov as well as there's this company, Gait. I don't know if you're familiar with them. They're taking a different approach to prevent falls. They're doing some VR sessions on a treadmill to train the patients at high risk to gait better. And I think there are a lot of synergy between the two companies. I'll be happy to connect you to. They are FDA regulated, I think class 1 as well, and they have reimbursement codes, and they are selling in the US. So I think it's
Cool.
an interesting collaboration that can come.
Yeah, for sure.
Yes. Thank you so much. Thank you, everyone. It was great talk, Tyler, and I'm seeing great synergy between different people. I hope that you can connect with the audience, and definitely we need to have more and more those kind of the very simplistic, at the same time impactful product and with low cost that can help to reduce fall. As Shabnam mentioned, the fall incident, in particular when we are seeing in family members or parents, it's a huge issue. And footwear definitely is very important if we using a footwear to give them confidence to overcome their fear of falling. They become engaged in more daily physical activity. Definitely that's the best intervention that we can offer. And thank you so much again. Thank you, everyone. Happy Friday, and see you all next Friday.